All right, what we're going to talk about today is proportional lengths. And we're going to see this when we have like kind of triangles instead of larger triangles. What sometimes helps is to rewrite these two triangles. So here's your small one. And I'll kind of write that out here. And then I'll copy the big one. And also copy that out here. So now we can kind of see better, oh yeah, these are the two triangles we're looking at. These are the two that are similar to one another. So this is A, E, D. This is also A, and then C, B. So we know 27 degrees is angle C. We don't know angle B. Angle A just says is Y. Angle E is X. And angle D is 62. So just first, just talking about the angles, because these two triangles are similar, all the angles that are corresponding to each other are congruent. So X is also 27 since C corresponds with E. So X is 27. And angle B would also be 62. And now that we know two angles inside of that triangle, we can add those up, 27, 62, and take that away from 180 to find angle Y, which is 91. Then we'll do proportional lengths. So we'll set up a proportion, we'll cross multiply, and we will solve. So now let's talk about the side lengths. It says CB is 28. It says C to A. So you want to be careful about CA. CA is not 15 because CA goes all the way to here. It's 15 and 9. So CA is 24. Meanwhile, EA is just that 9. Only CE is 15. And then we have AB. AB is not 6. It's 6 plus this little bit extra dB amount. So we'll have to kind of figure that out at some point. So AB is 6 plus whatever dB is. So what is in proportion here is we know that we have ED side and CB side corresponding, and then we have EA and CA side corresponding. So I would set up a 24 to 9 ratio, which would reduce by 3, so 8 to 3 ratio. And I'll set that equal to the 28 CB side to the ED side we don't know. And then I would cross multiply and solve. So 28 times 3, and then 8 times ED is 8 ED, divide by 8. So I get ED to be about 10.5. Then to find the length of DB. So DB is just that small portion from here to here. So in itself, that side is not part of a single triangle, or not, it's like its own side length of a triangle. It's part of AB, but it's not the entire thing. It's just that one portion of it. But what we can do is try to determine that we know that AD is a ratio of 6, and we still have the scale factor of 8 to 3. So if I use the same scale factor, but proportion of 8 to 3 from the big triangle to the little triangle, then I know that AB would correspond to 6. And that would tell me AB should be a total length of 16. Now, since AD is already 6, that leads me to believe that DB must be 10. And we just answered the question for AB. It was 16. So what we can do here is there's other proportions involved from like certain length and ratios. So we can set up this proportion. I'll do this in a different color. This is a side length of the small triangle. This is a continuation of the big triangle. I could make a proportion a 9 to 15 ratio as long as I correspond similar sides on the opposite side, like A to D and D to B. So I could also say 9 to 15 from here to here, it corresponding from 6 to this unknown. So 6 to the unknown. If I cross multiply this, I can also get 10 for that side length and find it that way as well. So you're allowed to set up those proportions. So for example, in this triangle embedded inside of a larger triangle, we have R could have a ratio with S that's in the same proportion of A relating to B. That's an equivalent proportion. And you can see that's one of our results right here. So that is a true proportion. So it's not C. We can look at the proportion x to s, so the total length compared to the small length, as long as we did the same pattern on the other side, the total length compared to the small length. So we do have x over s equals z over b, so that can be true. If you look at m to z, so this bottom length to that right length, we can do the same pattern of the smaller triangle. We can do n to a. So that's a true proportion. Excuse me. The one that's not true is what's left. M over s is not equivalent to n over r. And you can see that like this and this is, the r is a little bit bigger than the n, whereas m is ginormously bigger than the s. So there's no way that proportion holds true. So D is the answer. That one's not correct. Skip 3 and 4 and 5. That's just review from stuff we did last week. This is nothing new. All right, let's do a few more together, and then the last page will be your homework. So, to solve for x, you can do this in a couple ways, but the way that I like to do it is I like to draw out the small triangle again, and then draw out the big triangle. We know the small triangle is x, 16, and 10. We know the big is 40, 30, and then this whole thing is z. We don't know. I'm going to write this a little neater. That's 10. That's 16. All right, so I can separate proportion, a scale factor of a 16 to 40 ratio, just looking at these bottom sides here. And that reduces to, what, 8 goes in there twice and 5 times, 2 to 5 ratio. And then solve for x, I'll do an x to 30 ratio. So that tells me x should be 12. You can cross multiply and solve, or just know times 6 is how you can continue this proportion. All right, y. Y is just this portion over here. So once I figure out what z is, I'll just take away that 10, and that will tell me what the y portion is. So looking at the z side, that's over here. I'll do the same scale factor, a 16 to 40 or a 2 to 5 ratio. And then I'll do a 10 to z. So that tells me z must be 25, which helps answer this problem. And if z is 25, that means y must be 15, so these add up to 25. All right, next one here. We can do the same thing. We can blow out the two triangles, or another way we could do this is set up these similar ratios. We can do a 9 to 18 ratio as long as we compare it to a 6, and I'll just call this, I'll temporarily call this x, to x ratio. So this is actually side dB. Let me just label it dB so we don't confuse it with the actual x. So 9 dB, dyslexic, dB equals 18 times 6. Divide by 9. Get the length of dB to be 12. And we could have reduced that and just saw a 1 to 2 ratio. Okay. Then for the angles. In this angle, I know that's 150. So then this must be 30 degrees. And if that's 30 degrees, because these are triangles that are similar, they tell us that at the beginning, that this must be 30 degrees. And then same with this angle and that angle. So this must be 62 degrees. And once we know two angles in a triangle, we'll just subtract 180 to get the third. So y must be 88. All right, then continue to get the rest of the sides. AB we now know is 6 and 12, so 18. And CB, the easiest way that we might want to do this is think about the proportion of the triangle. So we have a small triangle, then we have the large triangle. The small triangle base is 10, the large is CB, we don't know. The length on, let's say, the right side is 6, and now we know the length on the right side is 18 for the big one. So we have a 6 to 18 ratio, or a 1 to 3 ratio. So that tells me CB must be 30.